Good morning, all of you. In today's lecture of class 11th mathematics, we are going to discuss our exercise 1.2 and basics of exercise 1.3. Our first question is, which of the following are examples of null sets? What is a null set? That has no element in it. So I think you can find them. First is set of odd natural numbers divisible by 2. We know, first question, first part, odd numbers that are divisible by 2. You have to form a set of like that. But we know that no odd number is divisible by 2. So what we can say, our set A is 5, or we can write it as this. That means it is an empty set. Okay. Next part is set of even prime numbers. We know that 2 is only the even prime number, so our set B will be into. Therefore, it is not a null set. Third is x is a natural number. In third, x is a natural number where x is less than 5 but greater than 7. It is not possible that a number is less than 5 and greater than 7. So we can say our set is 5, means does not contain any element, so it is also null set. Similarly, in fourth, y is a point common to any two parallel lines. Now, if two parallel lines are there, that means that there is no common point between them. Okay, therefore this is a null set. So our fourth is also a null set. Okay. Similarly, in second question, you have to find whether the sets are finite or infinite. Okay. Second is set of months in a year. Months are finite, so first is finite. Why? Because our set A will be what? January, Feb, that is approaching till December, so it is finite. Second is, in second they have written natural numbers in such a way 1, 2, 3 and this. That means no number is written at last, means the set is moving on, it is continuing. And I have told you that whenever we have this at the last of any set and no number is written there or any word, that means the set is infinite. Okay. Similarly, you can solve third question also and remaining parts of second question. Now question number 4. In question number 4, you have to check whether A is equal to B or not. Means you have to check, we are given two sets A and B, and we have to check whether A is equal to B or not. So first is given, A is given to us A, B, C, D, and B is given to us D, C, B, A. Now you can check. A is in both of the sets. B is also in both sets. C as well as D is in both sets. And no element in B or A is there that is not consisting in the other one. That means A is equal to B. Okay. Similarly, you can check last. In last fourth part, they are given us A as a set. X is a multiple of 10, means set A is multiple of 10. That means 10, 20, 30, similarly going on. And set B is given to us 10, 15, 20, 25, like this. Now you can check that 10 is in both terms, 20 is also there, but 15 in B is not in A. Therefore, A is not equal to B. And why it is there? It is because 15, 25 are the elements of B that are not consisted in A. Okay, I hope it is clear to you. Similarly, in fifth and sixth question, you have to check that which of the sets are equal. I hope you can do them. Now we can start the basics of our exercise 1.3. In exercise 1.3, we are going to talk about subsets. The main topic of exercise 1.3 is subsets. Exercise 1.3, that we are going to talk about subsets. What do you mean by subsets? Is that first of all, consider we are having two sets. Okay, set A is say 1, 2, 3, and set B is 2, 4, 6, 1, 3, 5. Okay. Now you can check that A is not equal to A, because four, 6, 5, these are the terms that are not consisted in A but in B. But you can check that every element of A is in B. Okay. And subset means what? Part of a set. Okay, means because every element of set A is included in set B, whether B has more elements, but every element of A is in B, therefore A is a subset of B. This sign means subset. This sign represents subset. Okay, that means if A belongs to this A, here A is any element of set A. If A is any element of set that belongs to set A, then A is a subset of B if A belongs to B. Okay, that means every element of A must be included in set B, only then A will be a subset of B. Otherwise if A belongs to B, if this A belongs to set A and A is not a subset of B, that means any one of the elements of A is not included in B. You can consider our example that A is set 1, 2, 3, and if we remove 1 from here, whether 2 and 3 are present in the set but 1 is not present, that means A is not a subset of B, and this represents not a subset. Okay, now there are now let us consider some important points about subsets. Okay, first thing, if A is a subset of B and B is a subset of A, if and only if A is equal to B, this means if and only if. Okay, now what they have said, A is a subset of B, that means, and B is also subset of A, that means say A is 1, 2, 3 and B is also 1, 2, 3. Okay, now to that A should be a subset of B, every element of A should be in B. It is there. Similarly, for B to be a subset of A, every element of B must be in A. You can see it over there. And also you can check that A is equal to B, because all the elements are same. That means if A is subset of B and B is subset of A, it is possible only and only at that time when A is equal to B. Okay. Second is, every set is a subset of itself. Okay, that means if we have any set A, then A will be its own subset. Okay, now third thing, phi means empty set. Now empty set has no elements, so phi is a subset of each set. Okay, phi is subset of each set. Okay, now point number 4, if A is subset of B, okay, and A is not equal to B, means all the elements of A are not equal to all the elements of B but included in B. That means A is called a proper set of B. Okay, and B is called a superset of Okay, I hope you understood it. And last thing, fifth, that suppose we have A be any element, any set, sorry, who which has only one element, say Z. Okay, means it has only one element. That means A is a singleton set. Okay, means if any set has only one element, that set is called a singleton set. Okay, now you can solve this example number 9, 10 and 11, that are example 11 we can solve now. 9 and 10 you can solve on your own. Example 11 is, let A be 3 sets. A, B, C be 3 sets. Okay, that means in 11th example what they have given to us, A, B and C are 3 sets. Okay, A belongs to B. A belongs to B and B is a subset of C. Okay, look, this belongs to and subset means are different. Okay, is it true that A is also a subset of C? Now we have to check whether A is a subset of C or not. Okay, now they have given us answer no. Why? You can check it now. That is, they have taken an example that A is this. Okay, it is one of our sets. B is this. Okay, why I use double brackets here? Because they have said A belongs to B. That means A is one element, complete set A is one element of B. Okay, if they have given A is a subset of B, that means in that case we would write A 1, 2, 3 in this way. Okay, but as they have given A belongs to B means this A is one of the elements of B. This is our A, and to this, how this can be an element of B? In this way, that now in this case we will consider 1 along with this brackets as one element of B. Okay, now they have considered as set C as the same as B. Okay, now you can check that B is a subset of C. B is a subset of C and A also belongs to B, but A is not a subset of C. Why is it so? Because 1 is an element that belongs to A. Okay, 1 is any element that belongs to A, but 1 is not an element in C. Okay, because 1 along with these brackets is one element, but only 1 cannot be considered as element of C. That's why we can see that A belongs to B, B is the subset of C, but A is not a subset of C. Okay, so you can try to solve exercise till these basics. The remaining, that is interval and power set, that we will discuss in our next lecture. Okay, thank you.